Well, my office is in my den, and the den is near the washroom, and my wife is coming by here to do some clothes, so I hope it's not too distressing or disturbing or whatever else. Okay, so here we see we have natural logs, and this is the expanded form. So we have to put it in its condensed form, so it'll be natural log. Now this is going to be x squared minus x minus 6. And subtraction is converted to division by x plus 2. And then this equals 2. But before we go any further, we can do a little bit of factoring here. So natural log and this is going to be x, and this is going to be x. Now before this was a 6 and a 1, but this is going to be a 3 and a 2 now, because I need to get a negative 6 here and have a difference of 1 in the center. So if this is a negative, this would be a positive. Ah, interesting. Now here we can cancel this out. So we have natural log of x minus 3 equals 2. Now this is in its logarithmic form. We want to put it in its exponential form. So let's do that up here. So what would my base be here? Remember, our base is e. This is a natural log. So we have e. Our exponent is going to be 2. And we have here our answer is x minus 3. Alright, so not too bad, but again, we're using those skills that we've been working on in the last few sections. So we want to solve for x, so we have e to the second, transpose this negative 3 over to this side, and we get a positive 3, and that's what x equals. Now you can just put this in your calculator. E to the second plus 3 will give us our answer. Alright, let's check it out. Oh, I should erase this here. Okay. So this is what we've done. We're now going to factor this trinomial. Cancel out the common factors to simplify. We get this. Now we're going to convert, let's go back one here. This is base e to the second power equals this. And that's what they have. Base e to the second power equals this. It's on the other side. So they're going to solve for x by transposing the 3 to the other side. And e to the second is this, plus 3 gives you this for an answer. All right. So this one wasn't too bad. Again, we're using those skills. All right, now we're going into what is called change of base formula. And we had said the shortened form of this is if you have it in this form, you can use change of base formula. So it would be log, and our base here is going to be base 10, log of x divided by log of b. And it's just that simple. Okay, let's go on and see what our problem would be. Now, you write this down. So, use change of base formula to evaluate the expressions in part A and B and to solve the equations in part C. So here, keep in mind we can convert this to base 10, or we can convert it to base E. So this would be log of 3.42 divided by log of 2. And let's see what we get here. Now they're using natural log first. Now you can do that, or you could have used the common log. Works the same. We had proved that earlier. And then now they're using what I did, and common log. You can use either one, and they give you the same results. So as not to make this too long, we'll stick with the book's version here. It'll be log of this divided by log of 3. So log of this divided by log of 3. And it gives you this answer, rounded. So again, you want to be writing this in your notebooks. Example 4, Part B. And now we're going to use change of base formula to find the value of x accurate to the nearest 10,000ths. Okay, so I started this one a little bit. We're going to convert to its logarithmic form. So the log, but I'm also going to use base 5 here, of 5 to the x power equals log base 5 of 16. So this is a little bit tricky here. But what do you notice over here? When we have base 5 of 5, this is just going to be x then on this side. And now what the book is showing, and you could have used log here, but they're converting it to natural logs. So the natural log of this 16 divided by the natural log of 5, put that in your calculator, and it gives you your answer. So kind of some tricky stuff going on here. Let's take a look to see where things are going here. Because the base is 5, we can take the log base 5 of both sides. This method is not necessary, but it does show how the change of base formula can be used. All right. So there we have this. We're going to go log base 5 of 5 raised to the x. Remember, this arrangement, when the base and this part of the answer with an exponent, it just becomes the exponent x. So we get x then on this side equals this. Now they're going to convert it to natural logs. The natural log of 16 divided by the natural log of 5 here. Change of base formula. Ooh. And then when you were to convert this, you get this, divide it, and it rounds off to 4 places this. Wow. Okay, well, these are some more problems. This has been 50 minutes, more or less. So we're going to pass this up here. But if you want to work on anything, there are the examples, And there are the answers. Okay, we finished chapter 10. We'll skip chapter 11 and we're going on to chapter 12. All right, see you soon.